In this video, I'll be explaining linear programming problem using Simplex method. Solve the following linear programming problem using the Simplex method. The question is maximize z equal to 12x1 plus 15x2 subject to 14x1 plus 9x2 less than or equal to 180, 8x1 plus 18x2 less than or equal to 144, where x1, x2 is greater than 0. To solve this problem, we need to first of all change the inequality sign to an equation and also add our slack variable. Here we have less than, so we are going to add the slack variable. Please note, if you have greater than, you will subtract surplus variable. But here we have less than, so we're going to add our slack variable. So this is our solution. We are going to add the slack variable here to our constraint. Here we have two constraints. So to add our slack variable, we have 14x1 plus 9x2. To add the slack variable, since this is less than, our slack variable plus x1 equal to 180. For the second constraint, we have 8x1 plus 18x2 plus x2 equal to 144. After adding your slack variable, so we're going to add the slack variable to our objective function here. So this is the objective function. We've added slack variable x1 and x2. So we're going to add here 0x1 because there's no coefficient plus 0x2 to our slack variable. So we're going to represent this on the table. To represent this on the table, we have CB, CJ, solution, the ratio. CB is the coefficient of the basic variable. CJ is the coefficient of our objective function, and ZJ. From the question given to us, this is our objective function. And the coefficients, we have 12, we have 15, this is 0 and 0. So we're going to represent that. So to represent that, we have here 12 for x1, we have 15x2, 15, and the basic variable is x2. For the third one, we have 0x1, we come here 0x1. For the last one, we have 0x2. 0x2. The next thing to do also is to fill these constraints 1 and 2 into the table. So here we have 14, 9, x1, 1, and there's no x2, which represents 0. So from our constraints, we have 14x1. So under x1, we have 14. The next one is 9s2. Under s2, we write 9. The next one is x1, which is 1. We write 1. And there's no value for s2. We write 0. For the second constraint, we have 8x1. So we have 8 here. The second one, we have 18. We don't have x1 here, so we put 0. And for the last one, we have s2, which is 1. Column for solution, here we have 180 and 144. So we add 180 and 144. To add your basic variable to the column, we need to find our identity matrix. So from the table here, we could see x1 and x2 form the identity matrix. I'm going to show you what I mean by identity matrix. When you talk about identity matrix, for example, we have the one for 2 columns and 2 rows. We have 1, 0, 0, 1. For 3 columns and 3 rows, we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is our identity matrix. For 4 columns, we have 1, 0, 0, 0, we have 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So this forms the identity matrix. So from our table here, we could observe that x1 and x2 forms the identity matrix, 1, 0, and 0, and 1. Therefore, we have x1 and x2 because they form the identity matrix. And what is the value for our x1 and x2 from our objective function? So from our objective function, so the value for x1 and x2 is 0, 0. We represent it on the table. So we have 0, 0 here. The next is to find our zj. So the formula for our zj is CB inverse of B A J. To find our zj, we have 0, which is CB here, 0 times 14 plus 0 times 8. So 0 times 14 is 0, 0 times 8 is 0, 0 plus 0 is 0. 0 times 9 is 0, 0 times 18 is 0, 0 plus 0 is 0. 0 times 1 is 0, 0 times 0 is 0, 0 plus 0, 0. 0 times 0 is 0, 0 times 1 is 0, 0 plus 0 is 0. So after finding the value for Cj, the next is to find our reduced cost. To find our reduced cost, this is the formula. We have Cj minus Zj. So since this is a maximization problem, the formula for finding reduced cost is Cj minus Zj should be less than or equal to 0 for you to reach optimality, or Zj minus Cj greater than or equal to 0 to reach optimality. So I'm using this formula, this first formula. If you're using this formula to reach optimality, it should be less than or equal to 0. That means all your values should tend towards negative, 0, negative. Why? If you're using this formula, all your values, for you to reach optimality, your values will tend towards the positive. Anything greater than or equal to 0 should be 0, 1, 2, 3, 4, So anything less than 0 is 0, minus 1, minus 2. So, but I'm using this formula. You can as well use this formula. It depends on your choice. But take notes, if you're using this formula to reach optimality, it should be less than or equal to 0. If you're using this formula, it should be greater than or equal to 0 for you to reach optimality. So I'm going to show you what I mean. So from our value here, the reduced cost, Cj minus Zj, remember, for me to reach optimality, it should be less than or equal to 0. So the formula for this is Cj. Look at our Cj here. This is our Cj minus Zj. That means we have 12 minus 0 will give us 12. 15 minus 0 will give us 15. 0 minus 0 will give us 0. 0 minus 0 will give us 0. The values for our B is 180 and 144. So we have 180 here and 144 here. So we can as well do what we did here. 0 times 180, 0, 0 times 144, 0, 0 plus 0, 0. And from this table, we've not reached optimality because we still have positive values. Remember I said if you're using this formula for maximization, it should be less than or equal to 0. So the next is to get our key column. To get your key column, we choose from the reduced cost the maximum number, which is 15. So this is our key column here, because 15 is the maximum number. So after getting your key column, you find your ratio. So your key column will help you to find the ratio. And to find the ratio is solution all over your key column. So here we have 180 all over 9. 180 all over 9, which will give us 20. Here we have 144 all over 18. 144 over 18, which will give us 8. After getting your ratio, the next step is to get our key row. So the ratio will help you to get your key row. To get your key row, you have to select the least values. So between 20 and 18, Our least value here is 8. So this is our key row. So from your key row and key column, you get your key elements. So from here, we could see that 18 is our key element because this is where the key column and the key row, this is where they met. So 18 is our key element. So the next step is to draw another table. That is the first iteration. So from here, our key element is 18 with the variable of x2 and also this. So this is our living variable and this here is our entering variable. So we are going to represent that on another table. So to represent it on another table, we have this table. So we'll still have the same number here. We still have our objective function. We still have the same number, the number which was in our formal table. We are going to represent it in the new table, which is here. Here will be x1. Remember, this is the living variable and this is the entering variable. So we have x2 here. So we have x2 here. So the next thing to do is to divide this number with the key elements. So we are going to divide this row with the key elements like 8 over 18, 18 over 18, 0 over 18, 1 over 18. So here we have for the first column here. For the first column, which is 8 over 18, we have here 4 over 9. So we have here 4 all over 9. 18 over 18, we have 1. We have 1. 0 over 18, we have 0. We have 1 over 18. 144 over 18, which will give us 8. The coefficient of x1 here is 0. We add 0 here. And for x2 here, the coefficient is 15. We add 15. We put 15 here. The next step is to find the values of this x1, the new values. So I'm going to show you the trick on how to get your values here. So to get the new row here, the new values that should be here, remember here is our key elements. From the old table, we have 18. Here is our key element under S2. So the same thing, here is our key element, which is 1. So the trick here is the numbers that should be here is 0. And to get that 0, we need to use this old number. I'm going to show you the trick on how you can use this, to get the values of what should be here. So first of all, we are going to write these out. So to write these out, I've written them out. We have 4 over 9, 1, 0, 1 over 18, and 8, which is here 4 over 9, 1, 0, 1 over 18, and 8. And also to get this x1, we consider the old table here. We consider the old table. We have 14, 9, 1, 0, and 180. Represent it here. We have 14, 9, 1, 0, and 180. Because we have 14, 9, 1, 0, and 180, which is here. And remember, this is our key element. So to get the value of what should be in our new number, I've taken the x1 from the old table. The trick here is to multiply these key elements with the adjacent value. The adjacent value is 9, but we multiply it with the opposite sign in order to get 0, because the plan here is all the numbers here adjacent to this key element should be 0. Just take note. So to get 0, we need to multiply this, the key element, times minus 9. So let me repeat it again. The trick here is to multiply the key elements, which is 1, is to multiply the key elements with this adjacent value, the opposite of the adjacent value. Remember here we have plus 9. So to multiply this, we have to multiply it with minus 9. So that when we multiply this with minus 9, when we sum the two, we have 0. That is what we just want to get. So this applies to all the values here. We'll multiply this with minus 9. we'll multiply minus 9, minus 9, minus 9. The minus 9 is coming from the opposite of this value here. So our new value here is 9 into 9 here, 1. We have minus 1. So 4 times minus 1 is minus 4. 14 minus 4 will give us 10. So our new value here should be 10. So we write 10. For x2 here, 1 times minus 9 is minus 9. 9 minus 9 is 0. So we come here, write 0. Let's look for the x1. So for x1 here, we have 0 times minus 9 is 0. So 1 plus 0 will give us 0. We add 0 here. For this one, S2, for x2 here, we have here 1, 2. We have here minus 1, 2. So 0 minus half, because here we have 1 over 2. 0 minus half will give us minus half. So here we have minus 1 over 2. We also consider that for here, which is this. Minus 9 times 8, we have minus 72. And 180 minus 72 will give us 108. So here we have 108. Therefore, the next is to get our zj. To find the value for zj, 0 times 10, 0. And 15 times 4 over 9, we have 20 all over 3. So from here, for here, 0 times 0 will give us 0. 15 times 1 will give us 15. 0 plus 15, we have 15. For here, 0 times 0, 0. 15 times 0, 0. 0 plus 0, 0. 0 times minus 1 over 2, we have 0. 15 times 1 over 8, we have 5 over 6. So 0 plus 5 over 6, we have 5 over 6 here. For this column, we have 0 times 1 over 8, 0. 15 times 8 will give us 120. 0 plus 120 will give us 120. So the next is to find our reduced cost. So to find the reduced cost, Cj minus Zj. Our Cj is 12. 12 minus 20 over 3 will give us 16 all over 3. 15 minus 15 will give us 0. 0 minus 0 will give us 0. 0 minus 5 over 6 will give us 5 minus 5 all over 6. So from here, we've not reached optimality because we still have positive values here. So after this, we are going to find our key column. To find the key column, as I told you, you take the maximum number, which is 16 over 3. So here is our key column. So from the key column, you get your ratio. To find your ratio, that's your solution all over the key column, which is 108 all over 10. Here we have 108 all over 10, which will give us 54 all over 5. Same thing with this, 8 all over 4 over 9, and this will give us 18. So after this, we get our key row. To get our key row, we take the least number. So between 54 all over 5 and 18, which one is the least? I think here we have 10.8 as well. So 10.8 is the least value here. So this is our key row. So from our key row, we'll have our key elements. So from here, we could say that our key element is 10, because this is where the key column and the key row, this is where they joined together. So 10 is our key elements. So from our key elements here, which is here, this x1 is the living variable and this is our entering variable. So we are going to form another table. I will show you how it's being done. So this is our new table because we've not reached optimality. From our old table here, we have 12, 15, 0, 0. The same thing with our basic variable. So the same thing is here. So we don't need to change anything for our Cj. 12, 15, 0, 0. And our basic variable, we have x1, x2, slash variable x1, x2. This is our leaving variable, and this is our entry variable. Another trick here is make sure from here we have this is the key elements. We are going to divide everything here with the key elements. So here we have 10 over 10, which is going to be 1, 0 over 10, which is going to be 0, 1 over 10, which is going to be 1 over 10, and minus half over 10. Remember, I said x1 is our entering variable. So we have 10 over 10 will give us 1 for x1. Give us 1. 0 over 10 will give us 0. For x1 here, 1 over 10 will give us 1 over 10. And 1 over 2 all over 10 will give us minus 1 over 20. The same thing with here. 1 over 8 all over 10 will give us 54 over 5. We have 54 all over 5 here. So the next variable is x2. We have x2 here. The coefficient for x1 here is 12. We have 12. And the coefficient for s2 here is 15. We have 15 here. So we are going to find the new value. This is our key element here, which is x1. The trick here is any value under the key element should be 0. So we're going to write out this value here. After writing out this value here, we will write out the old value for x2, which is the old value. We are going to write this value here and we do the mathematics. To write out this number, we have 1, 0, 1 over 10 minus 1 over 20. So this is the value 1, 0, 1 over 10, 1 over 20, and 54 over 5. For the second one, which is our old table, we have 4 over 9, 1, 0, 1 over 18, and 8. The same thing, we have 4 over 9, 1, 0, 1 over 18, and 8. And here, this is our key element. So the trick here is to multiply these key elements with the adjacent value, which is 4 over 9. And it's going to be the opposite sign because here we'll have plus. So we're going to multiply this with minus 4 over 9. The reason why is because we want to get 0. So the value under this key element should be 0, like the way we did in the first iteration. We have here 1 times minus 4 over 9, which is minus 4 over 9 plus 4 over 9, we have 0. Remember, this thing should apply to other values here. Minus 4 over 9 times minus 4 over 9 times minus 4 over 9 times minus 4 all over 9. So minus 4 over 9 plus 4 over 9 will give us 0 for x1. So we put 0 in our new table. We have 0 here. For this s2, we have 0 times minus 4 over 9 is 0, and 0 plus 1 is 1. So we have 1 here. We'll come here, we add our 1. For this row, 1 over 10 times minus 4 over 9, we have minus 4 over 90. So minus 4 over 90 plus 0, we have minus 4 over 90, which is the same thing as 2 over 45. Minus 2 over 45. So we'll come here, we'll write minus 2 all over 45. So for this row, minus 1 over 20 times minus 4 over 9, we have 4 over 180. So 4 over 180 plus 1 all over 18, we have 7 over 90. So we come here, we write 7 all over 90. So the same thing with this. When we multiply these two, 54 over 5 times minus 4 over 5, when we add these two, we have 16 all over 5. So we'll come here, we write 16 all over 5. So the next thing to do is to find our ZJ. So to find your ZJ, 12 times 1, remember I circled this because this is our key elements. This is our key element, so this is 1. 12 times 1 is 12. 15 times 0 is 0. 12 plus 0, we have 12 here. Same thing with 12 times 0, 0. 15 times 1, 15. 0 plus 15, we have 15. So we'll multiply these two. When we add them, we have 8 over 15. So when we multiply 12 times 1 over minus 1 over 20, when we multiply 15 times 7 over 90, when we add the 2, we have 17 all over 30. When we multiply 12 times 54 over 5, we multiply 15 times 16 over 5. When we add the 2 together, we have 888 all over 5. So to get your reduced cost, remember to get your reduced cost is Cj minus Zj. So our C here is 12. 12 minus 12, we have 0. 15 minus 15, we have 0. 0 minus this, we have minus 8 over 15. 0 minus 17 over 30, we have minus 17 all over 30. Have you seen from here, we've reached optimality because all the numbers here is less than or equal to 0. And we need to find the value for our z. So to find the value of your z here, that's the optimal value here, we need to consider the solution. So here, our S transpose here is everything in our B value, is everything in our solution value. So here we have x1 here to be 54 all over 5, x2 to be 16 all over 5. So we have x1 to be 54 all over 5, s2 to be 16 all over 5. The value for x1 and s2 is 0, 0. So from this x transpose, we get our optimal value. So from the objective function given to us, so this is our objective function here. So we are going to substitute those numbers into this value. So here we have 12x1 plus 15x2 plus 0x1 plus 0x2, which means 12x1, 12 times, we have 12 times 54 all over 5 plus the second value is 15x2, that's 15 times x2. We have 15 times 16 all over 5 here we have 0x1 and 0x2. We'll say 0 times 0 plus 0 times 0. So when we sum these two, we have 648 all over 5 plus, here we have 48, that's here 1, 3 times 16, 48 plus 0 plus 0. When we add this, we have 648 plus this is all over 1, remember? And this is our LCM. 5 divide 1, 5. 5 times 48, we have 240. So 648 plus 240, definitely here will be 0 plus 0. We give us 888 all over 5, which is the same thing as 177.6. So the optimal solution for this value is this. You can observe here that this optimal solution is the same thing with this value here in our solution. So that is the essence of getting this value here in your z, in the zj row. Because if you are not getting the same value, know that there is a mistake somewhere. For here, we got the same thing, so this is correct. This is how to know if your values are correct or not. And I will see you in my next lesson. Make sure you subscribe and also like the video and also put your comments. Bye.